Hey everybody, it's good to be back after being off of YouTube for such a long time. I was moving last year and boy, was that ever hectic. A bit more work than I expected, but I have a much better space to brew now, and so I'm excited to do some new videos showing off some new gear, some new techniques. What we're going to look at today is the first step in brewery automation. Actually, I think I'm likely to do a whole series on automation related topics over the coming weeks and months. Um, for an automated brewery, of course, we're talking usually about electric, although you could automate gas as well. In this case, we'll be focusing on electric. And one of the first things that you need to consider is how to get the power source into your brewery. Most electric systems are going to require at least 30 amps, but that could easily go to 50 amps depending on the size of burners that you need, and then also whether or not you want the ability to turn one or two on at the same time. So today we're actually going to be looking at how to get a 50 amp sub panel set up and run into a building that I'm using for my new brewery. So here's my little backyard brewing cottage, and on the rear of the building, the previous owners had installed a sub panel to power the building itself, and then also another panel to the left, which was powering a spa or jacuzzi at some point, which I was able to repurpose for delivering 50 amps into the building for brewing. So the panel on the right is the main sub panel at 70 amps. A 50 amp breaker is feeding 50 amps to the brewing sub panel here on the left. So let's talk about what we have going on in this panel. Starting at the wires coming in from the sub panel on the right, we have two blacks, a white, and a green. The two blacks are both hot. This is a 240 volt circuit, so each hot, each black is 120 volts. Then we have a neutral white, and green is ground. So our two hots are running to the hot bar on the panel. The white neutral is running to the neutral bar on the panel, and the green ground is running to the ground bar on the panel. Then we have our 2-pole 50 amp GFCI circuit breaker plugged into the panel, and this draws off the hot bar. And then coming out of the breaker, we also have two hots. The two hots coming out of the breaker are red and black. And then we have a neutral coming out of the breaker as well. And then we have the white neutral pigtail. And the function of this is to provide circuit completion for the internal GFCI circuit of the breaker. So you need to have this running back to the neutral bar as well. And it's important you don't skip this step or you won't actually have GFCI protection. So this bundle of wires exiting the bottom of the panel, again, we have two hots, red and black. We have a neutral, and we have ground coming from the ground bar. One detail worth pointing out is the neutral line coming out of the breaker, not the pigtail, but the neutral that's actually exiting the box, is somewhat optional. For this type of circuit, a 240 volt circuit, if you're not going to be powering any 120 volt components from the circuit, then you really only need the two hots and the ground. A good example of this is the device I currently have plugged in, the hose head. If you crack that open and look inside, they only have the hot legs and the ground actually wired up. The neutral is just kind of insulated and loose in the box. And that's perfectly okay. Again, if you're not powering any 120 volt components. And from here you can see we just go through some conduit and then into the building. So now on the building interior, that back wall is the other side of what we were just looking at. And here's the installed receptacle. 4 prongs, because remember we have 2 hots, 1 neutral, and 1 ground. This is the controller I currently have plugged into the said outlet. This is a bit dated. I don't think they're being manufactured anymore, but it controls 2 heaters, 2 pumps. You can see the cable on the left is what actually plugs into the receptacle, and then the 2 cables coming out the back are what supply the power to the individual burners. There's a small Raspberry Pi computer on the inside and some relays, and those enable you to turn the burners on and off and the pumps on and off with software. There's a very similar device now being made by a company called Brewing, and I'll provide a link to that in the description for anybody interested. For me, I've kind of grown out of this style of controller at this point, and I'm working on building a custom panel, which will most certainly be the topic of several videos to come. Okay, one practical consideration to cover that we haven't talked about yet is what type of wire do you need for a 50 amp circuit of this kind? So you need 6 gauge wire, which is quite thick and it's quite expensive and a little difficult to deal with. The exact type depends on how you run the wire. So if you run the wire, if you pull it through conduit, like I did for my building, this is what you need. This is THNN, I guess maybe called thin wire. Same gauge as what I'm going to show in the moment, but it's much easier to pull through conduit than like the bonded Romex type. So this is what you'll want to get if you're pulling through conduit. And these are probably the colors that you're going to want to use as well. Now, if you're running the wire like under your house and not through conduit, and you're just running from like your main breaker into another room, then you're probably going to want to use this. You can see that all the wires are bundled together. This is basically impossible to run through conduit. You just won't be able to bend it through. But it is what you want if you're just running like through your crawl space. Do be prepared to drop some coin on this copper. The 60-foot strand shown here is probably anywhere from, I don't know, $180 to $200 probably. And the price of this seems to just keep going up. So it's pretty expensive stuff. There's a lot of copper. So I hope this was helpful, taking a look at some of the basic panel wiring that's required to set up any sort of basic automation controller for electric brewing. I think the electrical side of this is probably the biggest thing, or kind of the thing that people fear the most moving into electric brewing. And it's really not too hard. Just be careful, take it step by step, be safe, and happy electric brewing.